Alright guys, so in this video we're going to talk about molarity. Now molarity is just basically a quantitative analysis of concentration. But before we talk about the numbers, let's talk about, just the qualitative analysis of concentration. What do we mean by concentration? Well, concentration essentially is basically, we're talking about the amount of solute in some amount of solvent. All right. And so when we're using the terms concentrated, all right, this simply means there's a high number of solute in solvent, all right? While sometimes when we use the word diluted or not as concentrated, we have some low number of solute in solvent, all right? So that's the way you could kind of look at it. So if you consider, so let's just draw like a particular model of this, what I'm saying. So let's say you have, here's beaker A with, these are good pictures of beakers, beaker B. And then we have some solvent, usually most cases a solvent's water, all right? And these particles are solute, all right? And so if you were to qualitatively, so just by looking at it, if you're just trying to figure, okay, which one is more concentrated, hopefully you start to see that beaker B is more concentrated simply because there's more solutes than there is in beaker B than you have in beaker A. And here you have less. So this is more concentrated, okay? And you can kind of think about it in many instances. So as if like, if you're drinking something and if it has a high concentration of sugar, it's very, very sweet, or it doesn't have enough sugar, it tastes very watered down. So these are just some of the way you could describe it qualitatively. Now, there's a way that chemists or scientists describe concentrations quantitatively, all right, or by using numbers. And this we simply call, or one of the ways that we do it is what we call molarity. Now, molarity, or big M, all right, is simply the amount of moles of solute dissolved in liters of solution. Okay, so that's basically it. In other words, if you just want to kind of look at it from more of a quick equation mathematical standpoint, M, molarity, is moles of solute over liters of solution. Okay, and so how do we typically use this? So like here's an example problem. If, let's just say, what is the concentration of a sodium chloride solution that contains 6.5 moles of NaCl dissolved in 3.2 liters of solution. Okay, so once again, remember molarity is big M equals moles of solute over liters of solution. All right, and so we could easily just draw out these numbers from the problem. So how many moles of salt you have? 6.5. How many liters of solution you have? 3.2. And then you just simply just put this into this. Well, you'll put this into the problem that we have here. So 6.5 moles of solution over 3.2 liters of solution, 6.5 moles of solute, I'm sorry, and 3.2 liters of solution. And then when you plug this into the calculator, then you see that you got roughly 2.3, or we say big N, we call molar or molarity, or the concentration of NaCl in the water is 2.03 molar solution. Okay. Now, there's just a couple other things that you just have to make sure you watch out for when you're dealing with this equation here, okay? And that what the units must be. So first, here must be in moles. All right, so like for example, if they started you out like the previous problem, I said that we have 6.5 moles of NaCl. What if I said I have 12.3 grams of NaCl? All right, if I had 12.3 grams of NaCl. Well, you cannot use this number and place it into the molarity equation. That's just not going to work. That won't happen. You have to convert this to moles first. All right, and you use the molar mass conversion for that to happen. And secondly, this right here, the liters solution, must be in liters. All right. So, like for example, if I said, the last problem I said 3.2 liters, but let's say if I started out with 250 milliliters. Okay. If I stated that, then you will know that you have to convert this to liters. And a way that you can kind of think about it, you should know that for every 1,000 milliliters is equal to 1 liter, or you just divide the number by 1,000, or you could just move the decimal 3 times. So here it's equivalent to 0.250 liters. Okay, so that's just one of the big things you just have to remember when dealing with um, these type of problems. That this number here, moles, must always be in moles. If it's given to you any units, you got to convert it to moles. And this liters must be in liters. So if it's in milliliters, if it's in deciliters, hectoliters, whatever the case is, you need to convert it to liters before you could actually move on. Okay.